Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Leah Roslin, the online editor for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We have muted the audio lines, but we welcome you to type in your questions for the speaker in our chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Eric Langer of BioPlan Associates.
Hello everyone. This is, as the introduction went, I'm Eric Langer, and I suspect if you're participating in this presentation, like myself, you're a bit of a data and information geek. So what we've done here is part of what BioPlan has done over years, which is take information and knowledge about the biopharma and biotech industry and put it into some context. In this case, what we've done is we've identified a very narrow slice of the biopharma industry, one operational area in buffer prep. What we did was created an economic model based on some of the costs associated with buffer prep. To give you some background information on the research, as you know, there are more facilities today than ever before are measuring their costs of operations. In the early days of biotech, much of the industry was centered around getting a product to market. Now, as the industry has matured and has experience in the bioprocessing aspects, now the critical issue is how can we do this more cost effectively, how can we improve our productivity, and how can we reduce our overall economic footprint. And buffer prep is one of those areas that is frankly not all that exciting. It's a stable, it's a critical area, critical operational step, of course, but it's frankly it's well known. There are many experts out there that understand how to do it, and it's done well. Very few failures. So one of the issues is, why do we want to make a change? So what we want, including even evaluating the make versus buy decision. So what we wanted to do was to accurately develop a model that could help support that make versus buy analysis. We did this by first identifying the expense factors associated with in-house buffer prep. We interviewed many people, and we've done this, by the way, over a number of years. So what you're seeing here is the aggregated analysis of multiple studies in this area. But for this particular analysis, what we did was evaluated the operational, the variable costs, the fixed costs, and many of the administrative costs associated with buffer prep. And being able to tease that data out of the broader manufacturing economics is often not easy. So what we did was we aggregated 10 end users representative end users buffer preps costs at different scales. Granted, this is not a fully quantitative analysis, but we believe that the end users we selected, albeit a limited sample, do represent many of the other industries. And what we did was when we required additional data, we employed end user supplied ranges of some of those data points. So we agree that there's a lot of variability in the processes and the individual facility usage. And those variabilities can make tremendous variation and divergence from the model. However, the model, I believe, offers a relatively rational starting point for evaluating the data, the ranges, and end users' costs based on actual experience in use. So what we've done here, and I believe is prepared something that you can use and evaluate as a starting point for your analysis of the costs. Just a very brief one-slide overview of what's going on in buffer prep. As you know, this is a major fluid used in bioprocessing. It's typically prepared in-house by rehydrating powders purchased from suppliers, and it's considered a core bioprocessing task, of course. Buffer fluids, however, can be a major bottleneck, especially in downstream processing. And as we've measured over the last 13 years in one of our annual reports, that impact on the downstream processing is becoming increasingly significant. So the question now is, how do you make those fluids in-house that require that dedicated space. It requires the equipment and requires a lot of staff logistics, as well as the regulatory and quality management. How do you make those decisions? And much of that is not necessarily exclusively cost-driven. So what we want to do is start by looking at some of these costs associated with buffer prep, and then move on to some of the other benefits and disadvantages of either in-house versus outsourced decision making. I want to start with one of the data points that we've got from our annual report, where we have identified 21 key outsourced activities, and we see that over the last 7 years there's been a rather significant increase in all outsourced activity. In particular, the downstream side, you can see that over since 2010, the percent of manufacturers outsourcing at least some of the downstream production activities is increasing, and that's likely to continue to increase. So just to revisit, when we look at the total in-house buffer prep handling costs, this analysis, what we looked at was, as mentioned, was 10 bioprocessing subject matter experts, and we used that input to calculate the buffer prep cost at their facilities. The resulting model estimates essentially the total costs of buffer prep from powders, and it compares those in-house costs and processing options. The parameters, the cost parameters, including the facility and equipment amortization, fixed costs, the variable costs, we were able to tease out labor costs, as well, of course, as the consumables. In addition, the average annual total costs for in-house buffer prep at various sizes and scales, and as well as at various types, single-use versus stainless steel, we believe we have a relatively accurate analysis of how those costs lay out. We also were able to prepare a dollar per liter expense for buffers as expected. This, of course, decreases as scale increases. So for a given scale, we can identify what a typical, for a particular type of facility, cost per liter for buffer production ought to look like. Stainless steel facilities costs are, as you can imagine, lower than for single use. However, the stainless steel facilities surveyed tend to be larger. They were commercial scale operations, and we needed to take those into account. Average cost per liter. Here's just a quick analysis of what we found. Average cost per liter for in-house buffer prep by production scale. We found that at the smaller scale, as you can imagine, the cost per liter is going to be in the $29 per liter range. In the greater than million liters per year, we're looking at something in the neighborhood of $11 per liter. So some of the findings we found in this analysis in terms of total buffer prep, the total facility cost at the less than 100,000 liter scale was in the neighborhood of about $2.6 million. At the greater than a million liters per year, the costs were in the hundreds of millions of dollars per liter. And so, of course, you can see there's obviously a range when you hit those larger scales. In stainless facilities, the average buffer prep was about $13 million per year. But these included, of course, the large-scale facilities. The total single-use facility cost was more in the neighborhood of about $5.5 million per year. Very large stainless, the lowest in-house per liter cost. We saw an average stainless was, as noted, was about $12 per liter, and the average single-use facility was about $21 or $22 per liter. In-house buffer prep is more cost-effective in large, all stainless steel facilities preparing large quantities. That's not unexpected. In-house buffer prep using single-use generally is higher, as you can well imagine, than stainless, even at the same scale. That was an interesting finding. The outsourcing of buffers, of course, as you can well imagine, and we start to discuss the outsourcing of buffers, involves the transportation and shipping of water, and that's a major factor. However, the costs associated with that, the logistics and the shipping and the production those aspects from some of the outsourced buffer suppliers is beginning to be reduced. So those issues need to be addressed. We've got some slides here that compare some of the benefits and downsides of the in-house versus outsourced buffer prep. Here we find, as you can well imagine, some of the benefits of outsourcing buffer prep. Number one, of course, is that the outsourced buffer suppliers have significant expertise in buffer prep, in particular with that buffer prep, because they're doing that over and over. Many of the large stainless steel facilities have that same expertise. However, that's not necessarily consistent across the board. Vendors provide, as you can imagine, GMP-level processing. They require provide the related documentation. They can provide the delivery and logistics, as well as problem management and investigation. Facility, an individual facility that does the outsourcing can take that space and use that suite that might be a buffer kitchen or a media kitchen, and use that for something that may be more efficient in a buffer rather than buffer prep. It also results in lower capital expenses, and of course, those people that are doing the staff costs that are doing that media kitchen and buffer kitchen work would be allocated somewhere else. The cost for buffer fluids is known up front, and for some facilities, that cost allocation becomes important. The supply chain is potentially more reliable. Buffer availability can be considered guaranteed as based on a contract. And customers can arrange that just-in-time inventory to reduce the handling and storage complexities and costs. The downsides, of course, and this is a major one, is the loss of control of buffer prep if that's done by a supplier. Obviously, that's in some situations that's a critical component, and as this industry moves more toward continuous bioprocessing, obviously that becomes an even more significant issue to consider. The logistics associated with the fluid management there. Outsourced buffer prep and acquisition and total costs are higher than in-house. That's some suppliers, by the way, have noted that they believe these costs may actually end up, if they're not already, they may end up being lower from various reasons like economies of scale than they could be done in-house. And that's part of the reason we're doing this model, is that in some situations it may be more cost effective to outsource than to do it in-house. Once outsourced buffers are delivered, you'd still, this is again a downside, once they're delivered, you still have a certain degree of the similar tasks, including the logistics, the handling, cold storage. Some suppliers have, on the other hand, have been offering buffer storage and just-in-time inventory. And lastly here, vendors generally only prefer to prepare buffers made from powders that they manufacture, not other manufacturers. Obviously, that's different from supplier to supplier, and whether you're not working with a CMO or a supplier in those terms. The benefits to in-house buffer prep, on the other hand, is the total cost for in-house prep is considered less today than it would be for outsourced. The full process control is retained in-house. Potentially there are more options for choices and selection of buffers versus vendor-prepared fluids. Preparation from powders, from classic industry approaches, it's a lot of experience out there already. Many of the buffer prep technicians are really good at it, and many consider there's no reason to change. Powder storage versus liquid, of course, takes up less space. The costs are less versus fluid storage, and powders can be stored for a long time versus when you have a freshly prepared fluid, then that has a shelf life. So when we look at the downsides of in-house buffer prep, the capital costs, capital investments, of course, are going to be significantly higher. You need that from a downside of having to have that done in-house. You need to have the experienced staff. You need to have management oversight, and that all adds to the cost and the complexity of doing it in-house. You need to have more. There are more tasks and complex scheduling involved in staff time, and you frankly need to have a significantly more trained operational staff in that area. Total costs can be unpredictable, and that's not often something that manufacturers are going to be comfortable with. Another downside is that the quality documentation can make outsourced purchase for potentially more attractive for many facilities, especially those at smaller scales or those that do intermittent production. Facility space in some situations, in some regions, is very limited, and being able to manage that flex capacity can free up classified space so it can be used for more potentially beneficial operational purposes. And of course, you get to avoid the risk of contaminations associated with in-house buffer prep. So I want to review the model now and take a look at some of the inputs that we included as we evaluated this. Again, as I mentioned, we talked with many, I think as many as 40 different bioprocessing professionals to identify which were the major cost inputs associated with the buffer prep part of manufacturing. This is how the model looks. You can see it's relatively straightforward. So all that work, it boils down to just the things that are really critical. And the way this works is essentially, if you input your facility's data at this point here, then it will generally calculate out based on your capacity what your expected costs should be. And if you then modify from the model based on what the model is indicating is a reasonable range, you input your costs. Then coming from at the bottom end here will come your cost per liter. So by simply filling in these blanks here on the right side, you can identify what your total cost per liter is as well as your annual cost. And that was the basis of the model. To get to that point, though, we had to add essentially start with the fixed costs, analyze things like capacity, these expenses, buffer prep, building, excluding HVAC, etc., WIFI or RO skid costs, mixed buffer only storage holding. You can see there are a number of elements that go into the fixed cost. What you end up with, though, is a fixed cost per liter right there, and that fixed cost per liter then is additive to the other components. The next cost you'd look at would be a variable and staffing cost. Here you have issues associated with validation, logistics, quality control, IT setup, labor, annual operations for buffer prep only, regulatory repairs, and other general and administrative expenses. And again, you end up with a cost per liter associated with the variable cost and the staffing cost per liter. You then move into the consumables side of it, and you identify, this is, of course, relatively straightforward. You've got the data on this, what your buffer ingredients costs might be, other ingredients, if you're using single-use devices or filtration devices, your WIFI costs, if not elsewhere noted, and you may have disposal expenses, and you'll have potentially other consumable expenses. As you can see, there's a significant consumables cost here. So when you add it all up, you end up, let me back that up. When you add it all up, you end up looking at that original slide there, if we can get that to come up. And it'll look like this. So all these components that you just looked at will end up at this bottom number right there. To get to these numbers here on the side, the ones we talked about, to fill those blanks in, we found that many end users just did not know what their costs for their facility was. So what we wanted to do was make it, obviously, as we mentioned, every facility is different. So making a model that fits all sizes is just not feasible. So what we wanted to do was identify the fixed costs and fixed expenses associated with, let's see if that will come up, the production of a liter. So for each line item, we identified the ranges and identify what the average was based on a typical facility. Here you see the average total fixed costs, and down here you can see the average for capital expenditures based on a range of costs. This average number here, this $1.84, makes absolutely no sense to put it in there. There is no such thing as an average facility. So that's not what you want to be putting in. What you want to be looking at is your own experience costs And if you don't know that, then to take a look at the ranges, and that way you can make a much more educated guess or educated estimate on what kinds of costs you are going to be experiencing for each and every one of these line items. We do the same thing for the variable costs, and we are even able to tease out the labor costs associated with that. So you can see that as you add these components up, you get a relatively reasonable analysis, line item by line item, of where the average facility's experience ranges are. But again, and I reemphasize that these have to go back to inputting. The reason we did that at all was that they're intended to support the input of actual data in these columns here. So get back to that slide. We then look at, when we looked at some of the data to identify how the individual factors were affected by scale, we then developed a few data graphs here that can help us identify how the inputs would graph out when we looked at them based on scale. And what we saw was that, just as an example, if you're looking at the total cost of buffer by facility size, this is all in cost. As we mentioned, is approximately $29 per liter, and $2.6 million at this smaller range here, at the under 100,000 liters per year range. These are the sort of costs you get. When you increase the costs for each of the data points that we collected, you find that as scale increases, of course, cost per liter decreases. Right here you can see that a million plus is on average about $11 per liter, and the cost for facility is obviously for that buffer prep facility is relatively high. So you can see that this dotted line here provides a not unexpected curve in terms of scale versus cost. When we look at things like, come on up, we look at things like just the fixed costs. We see obviously a similar kind of a curve where the fixed cost at the 100,000 liter scale is in the $6-7 per liter range, and that decreases down to $1. This was a potentially anomaly from the data, but somewhere between the $2 and $3 per liter range based on facility size. When you look at the variable cost, this includes labor and other costs. You can see again it decreases at the 100,000 liter range. You're talking about $15 per liter and $1.3 million in expenses. And as you increase, it decreases down to $5 per liter at the million liter per year range. In terms of variable costs. When we teased out just the labor cost, for example, the labor costs associated with production, we find that you're spending about $7 per liter on labor. And we bring labor into the picture because the cost of the consumables, for instance, is not going to change much regardless of how you produce it. But this number here, in terms of labor, this one here may be the key factor in terms of how to differentiate an outsourced versus an in-house make versus buy decision. Again, you can see that the labor costs decrease, but not as much as they did for some of the other functions. They decrease because as you produce more, it's not a linear decrease. So you're looking at cutting it in half. The larger facilities are able to cut their labor costs in half in terms of how they price out that component. So when we looked at the variable costs, just as an example, the variable costs by facility type, stainless versus single use, we see that in terms of variable costs, overall, the variable costs associated with the stainless facility is about $7 per liter and about $12 per liter in a single-use facility. And then when we look at the overall graphic associated with when you add it all up, these are the two graphs in terms of how scale is affected by the cost is affected by scale. And you can see that at the very lowest scale for single use, the highest costs were in the $35 per liter range, and for single use, it drops from $35 to about $21 for single use. And when we look at the stainless, we're looking at all-in costs around $24 versus about $9 for the supersized stainless steel facilities. So to summarize some of our findings, obviously the defining in-house economics, the question that we're looking to answer is, can outsourcing buffers actually be economical? The question here is essentially, is it, and I have to ask, or interject there, is outsourcing buffers only an economic decision? And I think the answer to that is no. However, outsourcing decisions based on cost can be a first and frankly relatively easy task to be able to identify if you can show that that this element of the decision process in the make versus buy decision, the cost and economic factors, make sense, then it's easy to go on to the non-cost, the intangible factors associated with in-house versus outsourced buffer prep. The model that we just described can define the most critical experience factors, and this was based on, as I said, as many as 40 bioprocessing professionals who provided their expertise into identifying which the critical experience factors were associated with cost. It can then help support and define the priority versus the non-priority concerns. What you'd find is if you haven't developed a model like this, then you don't necessarily know even the approximate range of impact that WIFI might have on the decision, the economics versus, say, labor. Here you can put, you could at least put a number on those factors, and you can determine for your own facility whether or not this element or that element is a priority or a non-priority concern, and then move on to the more strategic issues. And ultimately, the objective of a model is to support that a rational decision-making process in the make versus buy decision process overall. So in summary, we've got to admit that there's huge variability in every single facility, and that variability means that the cost experience factors at each facility will be absolutely unique. There's just no way to be able to put together an effective model that's not cumbersome or overdeveloped that will help you individually assess based on broad factors. It requires going in there and putting numbers in that are directly related to your factor, your facility, and the factors that are most important to you. The factors should be evaluated using that actual in-house data. However, the ranges that we've provided based on the interviews that we've developed over to put this model together provide what I believe is a relatively good starting point to be able to quantitatively identify each individual line item cost factor and the ranges that may relate to your facility. As an example, if storage is a concern or is a factor, and you're in a low low expense region where the cost of land or the cost of storage is not that high, then you can look at the range and say, well, we're probably at the lower end of that range, even if you don't have a fixed number. On the other hand, if you're in the middle of an urban area and facility space is at a premium, then you might even go beyond the range and say, well, even though I don't have the exact number, it's probably higher than this because I'm in the middle of X, in the middle of a particular region. So by taking these numbers and taking these range, you can take that model and use it to develop it into something that's completely customized for your facility. And that alone is, I think, very valuable in terms of supporting that make versus buy decision.
Okay.
So
well, thank you, Eric. We do. Let's start with what is the optimal volume in which outsourcing begins to make sense from all this data?
That's a good question, and I think that kind of goes back to what we were talking about with as you develop a model. There really is volume is not necessarily the primary factor where you're going to consider beginning to that outsource decision. Really, while volume and scale is a critical issue, the economic factors that this is just a starting point. For example, if you're evaluating a large-scale facility's economies of scale, or the fact that they have a pre-existing media or buffer kitchen, or that they have lack of space, or that they have lack of capital or resources, these are all critical factors that need to be taken into account, not just the scale or the volume, not just we need X 100,000 liters. Another critical issue is the type of risk aversion needs to be considered. For instance, concern over loss of operational control is a risk. If some facilities that have high volume usage and realize that this is a zero failure game, are going to have a much lower risk aversion. On the other hand, concerns over in-house contamination may be a major concern if the facility if that becomes if that's one of the critical issues. Strategically, manufacturers' overall outsourcing philosophy may be one of the biggest factors. If there are some companies whose objective it is to outsource as much as reasonable, to put certain non-core or perceived non-core operations in the hands of perceived experts. That alone may be a major component in the decision equation. But in the end, it's going to be a function of all of these variables, and it's going to be the aggregate of those issues. But using a basic economic model is, like we said at the beginning, is the easiest way to address just the pure economics of it. And it will, assuming that that's step number one, then using a model like this can be a very efficient tool to get you through the question, is this economically sensible? And once you know that it's economically sensible, then you can go back and look at some of the other factors that may play into it.
And do buffer users prep and store buffer for each single purification batch, or do they prep and store large quantities at once from multiple batches?
So the question is, do buffer users prep and store buffer for each single purification batch? I think because what we were doing when we were looking at this analysis here was we were trying to identify the costs and not necessarily the operational steps or how they were doing this. So I think that while the question is clearly relevant, that becomes a question of that would be a function of the cost associated with the storage, and I'm not sure that we would be able to tease that.
Yeah, I was wondering, in this model, in the model that you use, what method were they using?
Well, remember we talked with a lot of people, and so typically, if we were to go down and actually that's an interesting question is were they using a media kitchen or an inline buffer dilution system or formulation? Those are all very good questions, and that therein is some of the problems that you have when you're trying to develop a model. If we start to add issues of, are you using IBD or are you using some other method, then if that became a major cost factor, then it would have likely shown up as when we were interviewing the bulk, the initial bulk of end users, and they would have told us IBD versus batch storage is going to be a major factor. Now that said, it might be that in inline buffer dilution there just wasn't enough of that even in the large group that we initially interviewed to be able to make that differentiation. So that is an example of where as you run through the model, you may need to say, well, this it does not account for X, and that might be one of those areas where it doesn't account.
Okay. Yeah, and it looks like we're getting a couple more questions that are really kind of specifically asking about what those, what those people that you interviewed were doing, and if you noticed any trends and where the bottleneck is or anything. But I don't know if you want to answer that or.
One of the questions is what bottlenecks do users have in single-use buffer prep and equipment storage? And I think that's a good question. I think that's something that I think we would want to identify some of those issues. I don't think that was part of this study. We weren't looking specifically at the kinds of bottlenecks and pain points associated with, say, single use. And obviously, there's a lot of experience in single use and buffer prep. So much of that is known. It just wasn't part of this specific analysis.
But did you account for facilities that have single use and stainless steel in their manufacturing processes?
Absolutely. Yeah, we separated that out. One of the things we wanted to do was identify the costs associated exclusively with single use versus exclusively or primarily stainless. And so when we categorized the organization, the facilities, we categorized them as such so that we could break out a single use versus a stainless facility and identify the costs, their specific costs associated based on their facility type. And that's where we came with some of those, developed some of those graphs.
Okay. Are there any more questions? Okay. Well, thank you, Eric, and thanks to the audience for joining us. The recorded version of this webcast will be made available for on-demand viewing on our website, and a registered attendee, you will receive a follow-up email directing you with that link.
Okay, thank you very much.